This is the homework for 115, 16, 17, 19, and 21. In problem 115, you need to draw figure 4. Well, here we need to look at the pattern. And if you look at figure 1, you have 2 greens and 4 blues. And you can see here is figure 1, but from figure 1 to figure 2, you're adding 2 more to the top and 2 more to the bottom, total of 4. Here's figure 1, figure 2, and adding 2 more to the top, 2 more to the bottom. So you can see that at a constant rate, you're adding 4 more tiles. So figure 4 would look like this. Here's figure 1, figure 2, figure 3, figure 4. And we could keep doing that for figure 5, and you just keep adding. You can also go the other way. If you're adding 4 to each figure, if you go back, you're subtracting 4. Subtract the 4 yellow, subtract the 4 red. Now here, to get from figure 1 to figure 0, subtract the 4 blue, and there's figure 0. For 15b, you need to find out how many tiles will be in figure 10. Well, one way to do it is just to keep adding them up. So in figure 1, you have 2, 4, 6, and you're adding 4. So that's 10, adding 4, 14, adding 4, 18, and you keep going till you get to figure 10. That works, but it is time consuming, especially if you were asked to find how many tiles were in figure 73. That would just take too long. So what I suggest is to come up with an equation for the pattern. And here we have y equals mx plus b. This is a slope-intercept form for linear equations. So the m is the rate of change, or slope. B is the initial value, what you start with. When you're graphing it, it's the y-intercept. So how would that help us? Well, here's figure 0. Here's figure 1. Figure 0 is what you start with. It's the initial value, the b, in the equation. And our rate of change, our slope, what we keep adding to each figure is 4. So each time we're adding 4. So our rate of change is 4. M represents slope. So if we use slope-intercept form, we can plug those values in. 2 for the initial value, m for the rate of change. So here we have 4 and 2. And now we can use this equation to find any figure. So for figure 10, x represents the figure number, y represents the total number of tiles, your input, your output. If you input figure 10, 4 times 10 is 40, plus 2 is 42. So figure 10 will have 42 tiles. And now that we have this, I could ask you, how many tiles would figure 1,372 have? And you could plug that in and find the total number of tiles. For 116, what value or values of x will make each equation true? So we're going to solve for x. X plus 5 equals 5. We want to isolate the variable. Inverse property of addition is subtraction. So we're going to subtract 5 from both sides. This creates a 0 pair. And 5 minus 5 also creates a 0 pair. So x equals 0. So this has one solution. The only value that will make this equation true is 0. Problem B we need to simplify the equation. So we're first going to combine like terms. On the left side of the equation, there are no like terms. Here we have 3x minus x, which equals 2x. 1 minus 7, more negatives than positives, so we know it's going to be a negative value. Signs are opposite, so I'm going to subtract. 7 minus 1 is 6, so it's negative 6. Now you can see that both sides of the equations are the same. Well, let's continue. Now we're going to do inverse property of subtraction is addition, so we're going to add 6 to both sides. 0 pair, 0 pair. And we're left with 2x equals 2x. Now I'm going to go ahead and divide both sides by 2. Inverse property multiplication is division. And here it created the giant 1. 2 divided by 2 is 1. 1 multiplied by x is x. And the same on the right side. 2 divided by 2 is 1. 1 multiplied by x is x. So all real numbers, there's infinite solutions. No matter what you put in the left side, the right side will also be the same. They'll be equal to each other. Problem C, 3x plus 1 equals 43. We want to get x by itself. So we're going to inverse property of addition is subtraction. Created a 0 pair. 43 minus 1 is 42. This is multiplication. Inverse property of multiplication is division. We created this giant 1. 3 divided by 3 is 1. What you do to one side, you have to do the other. 42 divided by 3 is 14. So x equals 14. This has one solution. 14 is the only value you can substitute for x, plug in for x, and it will make this equation true. Problem D, we want to get x, all the x's to one side, and I usually try to get it to the side that has the greater value of x's, but you can see they're both 4x's. So I'm going to start on the right side and bring them over to the left, and I'm going to go ahead and subtract 4x from both sides. Inverse property of addition is subtraction. That created a 0 pair, 0 pair. And what I'm left with is negative 1 equals 7. Well, that's not a true statement. So there's no solution. There's no value that I can put in for x and make this equation true.